Austep is an engineering and building company operating mainly in the private sector. It builds a plant for the treatment of waters, plant for the production of biogas from the fermentation of organic matter, both for the production of biogas and biomethane. The sector where Austep operates include water depuration, soil reclamation, reduction of sludges and production of biogas and biomethane, and also production of energy from dejections, from urban solid waste, from feed spills, from crop residues, and what is in general fermentable and putrescible. Austep has 40 employees, 50% of them are engineers and the rest is chemists, who all follow both the Austep laboratory and the startup of all the plants. Austep, since 1995, when it was set up, has designed and constructed more than 200 plants, including water purification plants and biogas plants. The plant that we have constructed for the Cremonini Group has been managed by Austep for 2 years, and in those 2 years Austep has gained a very wide experience both in the sector of nitrogen, with the opportunity of having very high concentration of nitrogen, and also in the organization of a completely new sector, namely continuous maintenance 24 hours a day, 7 days a week. We believe that after 2 years of maintenance and organization, the challenge of Austep in the sector of maintenance has been met. The Inalca plant is made by different functional parts. The first one is pre-treatment. Then we have the core phase, that is anaerobic digestions, and then we have 2 lines, the biogas line for co-generation and the digestate line. In pre-treatments we have a feeding of liquid and solid phases. Solid phases are fed by a hopper that feeds the biopulper, and the liquid phase is fed directly to the biopulper. We can feed up to 200 tons per day. The biopulper is a reservoir to prepare the mix that is going to feed the anaerobic digestion plant. We have 2 twin parallel digester, 3000 cubic meters of volume, that receive alternatively the prepared mix that is prepared and comminuted by the biopulper. The mix has to remain within the digester for 30-40 days, and after that the digestate is removed with a pump and transferred to the cool digester, and it follows the digestate line since now. The gas saturated with humidity is cleaned up for the removal of H2S, and it's ready to be transferred to the chilling plant and cogenerator plant. The biogas that is produced is approximately 8,000–10,000 cubic meters per day. It's very rich in methane. Energy produced by this biogas is 800–1,000 kilowatt per hour based on the quantity feed to the digester. As for the digestate line, we have a solid-liquid separation through a centrifuge. The liquid is pre-treated biologically to remove nitrogen before mixing these waters with that of the purification Inalca plant, whereas the solid part is dried up. The digester is conceived in a very special way from the viewpoint of construction. Differently from traditional digesters mainly used in the agricultural sector, this digester has a very special height and is more compact from the geometrical viewpoint, and from the viewpoint of mixing, this is a very positive aspect. The digester has a conic bottom to avoid heavy materials to remain at the bottom of the digester, so it remains always clean and functional. Another positive aspect of the digester is the cement slab top, different from traditional digesters. And it has two main advantages. The first one is the location of a vertical mixer at the top of the digester to mix vertically the content of the digester. The second reason, it enabled better isolation from the temperature viewpoint, and we have less oscillation of gas volume within the digester, and this is easier for the subsequent treatment. The innovation of this plant is represented by a number of aspects. First of all, the introduction of a biopulper system that has a special characteristic. As in food preparation, it takes the different ingredients of the recipe that will be fed to the anaerobic digester, it mixes them together in the correct doses, pre-treats them to comminute the various ingredients, and we have an homogeneous small dimension substance, and this determines a maximization of the energy yield and the production of biogas and energy from this biogas. Another very important aspect refers to the cleanup of the biogas. For the first time, we have applied a technology for the cleanup of the biogas that enables continuous control that is external to the anaerobic digestion vats. This implies higher safety and continuous control through a continuous measurement of the pH of the cleanup solution that enables continuous measurement of the quality of the biogas used to feed the cogeneration engine. The digestate is transferred to a plant for the removal of nitrogen, hence a continuous depuration of the digestate for the production of biogas. So there is no need at all of land for the spreading of digestate. In setting up the Inalca plant, we have learned how to treat complex matrices that never were applied in the past to anaerobic digestion. The plant taught us two important lessons. The first regarding training. Plants has to be correctly set up and designed and constructed, but also managed. The training of the staff is of vital importance to correctly manage a plant. Second lesson is that the management of the abattoir waste is not as simple as it may seem, and competencies gained during this 2-year period enabled Austep to become leader of the sector in terms of competencies and references.